इंजीनियरिंग मैकेनिक्स UT1 की क्वेश्चन बैंक, राइट. सो स्टार्ट करते हैं फ्रॉम द फर्स्ट क्वेश्चन. क्वेश्चन इज फाइंड द रिजल्टेंट ऑफ द फोर्सेस एक्शन ऑन पॉइंट P. सो फर्स्ट, ये कौन सा टाइप के फोर्स सिस्टम है? ऑल द फोर्सेस आर ओरिजिनेटिंग फ्रॉम अ सिंगल पॉइंट P. दैट मींस कॉन्करेंट फोर्स सिस्टम है, राइट. तो यहाँ पे हमें फाइंड करना है रिजल्टेंट ऑफ द force system. That simply means the equivalent single load which will produce the same effect as these four forces combined, right? तो इसको हम सॉल्व करेंगे by using the conditions. The horizontal component of these forces, the summation should be equal to the horizontal component of the resultant force, and the vertical component of the summation of vertical component of the forces will be equal to the vertical component of the resultant force, and then we can easily find the resultant force in direction as well as in magnitude by using the analytical method, right? So solve करते हैं इसको. 500 न्यूटन एक फोर्स है वर्टिकली अपवर्ड, then 450 न्यूटन हॉरिजॉन्टल फोर्स है, एक इंक्लाइन फोर्स है एट एन एंगल 30 डिग्री विथ हॉरिजॉन्टल, एंड एक और फोर्स है 250 न्यूटन. ओके, बट द एंगल इज नॉट गिवन, द स्लोप इज गिवन 3 वर्टिकल टू 4 हॉरिजॉन्टल. तो अभी हमें ये एंगल फाइंड करना पड़ेगा, राइट. द एंगल मेड बाय दिस inclined force with horizontal or either vertical. So let's say that is theta, right. This is 3, this is 4, and this angle is, let's say, theta. So using trigonometry you can find this angle theta. Use the relation tan theta. So tan theta is equal to opposite side. This is right angle triangle. So opposite side upon adjacent side, and then theta becomes tan inverse of 3/4. This is 36.869. You can take 36.870. Okay, this is point P. The angle of this force will be 36.87 degree with the horizontal axis. Okay, so first step क्या है इसमें? First हमें find करना है components of the given forces. If the force is inclined, we have to resolve the force into perpendicular components. One is along x-axis, one is along y-axis. That means vertical and horizontal components. So let me just copy this. 450 Newton towards right, 500 Newton upward, vertically upward, then inclined to 50 Newton, and 300 Newton at an angle 30 degree. So first we'll resolve these inclined forces. Okay, so this angle is given, and here again angle with horizontal axis is given. So first we need to understand how to resolve any given force, inclined force, into components. If this is your force inclined at an angle theta with any of the axis, then you can just simply draw a right angle triangle, and you can find the this height and this base of the triangle using trigonometric relation, and you will get this as f cos theta and f sin theta, right. So adjacent to the force will be your cos component, and this is same, right. So this force is equal to F sin theta, right? That simply means we can resolve the given force into components. One is cos component, one is sin component. Remember that cos component will be the force component which is always adjacent to the angle. Okay, so this is the basic resolution of forces. Okay, so this is going to be 250 and with angle means cos component, angle is 36.87 and this is going to be 250 sin 36.87. In the same way 300 cos 30 and 300 sin 30. Okay, first we have done the resolution. So we solve the forces along x and y axis. Okay, so first step, find the x component of the resultant and which is equal to algebraic sum of x component of all the forces. So first we need to assume suitable direction. For vertical forces, we will assume that vertical upward forces will be positive and downward forces will be negative. In the same way, towards right forces, horizontal forces positive and towards left forces negative. In the same way what we have assumed in graph, right? So x component of resultant force and it can be denoted as Rx and that is equal to what? Algebraic sum of x component of all the forces acting on the point P. The first is horizontal force towards right 450 Newton. Assumption is the forces acting towards right positive, towards left negative. This is 450 and one of the component of 250 Newton is horizontal component 250 cos 36.87, then 300 cos 30, but it is acting towards left side, so negative. To solve this, 390.19 and it is Newton, right? All the forces are given in Newton. Yes, in the same way, calculate y component of the resultant. This is positive, right? That means the x component of the resultant is acting towards right. It's y component. So y component of the resultant force. And here vertical upward forces positive and vertical downward forces negative, right? So in the same way, Ry is algebraic sum of y component of the all forces acting on the point P. So this is 500 Newton vertically upward. Then you don't need to consider this horizontal force. Then the vertical component of this 250 Newton force is downward, therefore minus 250 sin 36.87 and this component, vertical component 300 sin 30 downward again, so minus 99.99, you can write it down as 200 Newton. And again it is positive, that means it is acting vertically upward. Okay. So in the same way, what we have done, we have resolved the given force into perpendicular components. Now we are doing the reverse process, right? Composition. We'll consider these two forces and we'll find the equivalent inclined force. So Rx is towards right, 390.19, and Ry is upward 200 Newton. And the resultant should be somewhere here at an angle. You can assume any angle, let's say alpha, theta. Okay. So resolve this. For this, you will have to use this formula, resultant force R, that is equal to under root of Rx square plus Ry square half. The same way, using Pythagoras theorem. If this is your Rx, this is Ry. So, right, this should be your resultant R. If this is Ry, this is again Ry. And you can consider this right angle triangle where hypotenuse is R, and you can simply find the formula for R. So Rx is 390.19 and Ry is 200. So as it seems, the answer is 438.46 Newton. This is called magnitude. Magnitude of resultant force. And then we'll find the direction of the resultant force. Let's say this angle, theta, alpha, whatever you can take. Let's say theta. Okay. So using trigonometry, direction of the resultant force. Okay. So use relation tan theta. You'll get theta as tan inverse of Ry, opposite side upon adjacent side. So tan inverse of 200 divided by 390.19. $27.138, you can write down 14. So as it seems, the answers mentioned in the question bank are wrong. Your answer should be, theta should be 27.138 or 14, and the resultant is 438.46 Newton. ओके, तो ये एक कॉन्करेंट फोर्स सिस्टम है जिसका हमने रिजल्टेंट फाइंड किया. वी कैन आल्सो लोकेट द रिजल्टेंट. It is in the first quadrant as x and y component both are positive, and angle made by the resultant force is 27. So this should be your resultant force at an angle 27.14, where this R value is 438.46 Newton. ओके, अब सॉल्व करते हैं हम नेक्स्ट न्यूमेरिकल. राइट, सो दिस न्यूमेरिकल इज a general force system, right? So a body is subjected to forces at different location, and we are asked to find the resultant of the forces, and we need to locate it with respect to this point A. Okay, so this body is subjected to general force system. So what are those conditions? Same conditions. Whatever the x component of the resultant will be equal to so algebraic sum of x component of all the forces acting on the body, and in the same way the y component of the resultant is equal to algebraic sum of y component of all the forces, right? हमें रिजॉल्व करना है ये जो इंक्लाइन फोर्स है 200 न्यूटन, राइट? ऑल द रिमेनिंग फोर्सेस आर ईदर अपवर्ड और हॉरिजॉन्टल, सो वी डोंट नीड टू रिजॉल्व these 80 Newton, 100 Newton and 40 Newton forces. So we need to resolve this inclined force, right? So we will get one vertical component and one horizontal component, and the angle is again you can use this slope. Let's say that is theta. 3 vertical to 4 horizontal, then the theta is equal to tan inverse of 3/4, and theta comes out as 36.87. Okay, right. So this is general force system. One additional condition we need to consider is the algebraic sum of the moment. The force tends to produce rotation as well as translation. So we use moment concept just to measure the tendency of the force to rotate the body. Okay, which is equal to what? Force into perpendicular distance from the point of interest. So here we have been given A is the point of interest, right? So first we'll find the resultant of the external forces, 200 Newton inclined force, 40 Newton upward, 100 Newton, 80 Newton and one couple is given, 40 Newton meter, which is clockwise in sense, right? So here resolve the forces and we can find the x component of the resultant or component of resultant along x axis. Okay, so Rx is equal to what? Algebraic sum of x component of all the forces. Okay, so we have this horizontal force 100 Newton and the component of this force. This is going to be, if this is angle with horizontal is considered theta, then this angle is theta. This is going to be 200 cos theta and 200 sin theta, right? So we have one force 200 cos theta towards right, so positive, 100 Newton towards right, so positive. Only two forces are acting in the horizontal direction, 100 Newton assume the forces acting towards right positive and towards left negative. So 100 towards right and 200 cos theta, where theta is 36.87. 200 cos 36.87, and which is again towards right, so positive. Is equal to 260. The answer is 259.999. So obviously we need to consider the approximation here. 260 Newton. The unit of the forces are Newton, and the x component is positive. That means the direction of x component is towards right, positive direction. Same y component of the resultant or component of resultant along y axis. And here we will assume that upward forces are considered positive and downward forces negative. Okay. Then Ry, summation of Fy, and that is equal to this 80 Newton downward, 40 Newton upward, and 200 sin theta downward. So 40 upward, 80 downward. Okay. So 40 upward, 80 downward. Positive, 80 negative, and minus this force 200 sin theta downward, where theta is 36.87. फाइंड करते हैं इसका आंसर. And one more thing, always make sure that your calculator is in degree mode. Many of the students will make that silly mistake. The mode, if it is in radian mode and you are substituting your value of angle in degree, obviously you will get wrong answer. So here it is minus 160. And minus signs indicates that the resultant is acting in downward direction. So show that the resultant is y component of the resultant is acting in downward direction. Okay, and in the same way as previous numerical, find the resultant force or magnitude of resultant force. R, using Pythagoras theorem, Rx square plus Ry square. Rx is 260 and Ry is 160 square. Okay. $305.2867. So you can write 305.287 Newton. Yes, this given answer is correct, which is mentioned in your question bank 305. So we'll find the direction of the resultant. Next step, the angle made by the resultant with any of the axis, let's say with horizontal axis. So x component resultant क्या है? Towards right. Y component is downward, vertically downward. So towards right and downward. This is the Rx, this is Ry. So we are sure that your resultant will be something like this. So let's say alpha is an angle made by the resultant. Okay. So we can use the again trigonometric function. So direction of the resultant force. Alpha with any of the axis, let's say horizontal axis, and it is given by formula tan inverse of Ry by Rx. Ry is 160, Rx is 260. $31.607. Yes, this is again correct. They have considered angle as theta. You don't need to consider any particular notation. You can consider any notation. Now next point in this is the position with respect to point A here. Okay, so this is general force system which will obviously produce the rotation as well. So with respect to point A, where is the force acting? Right. So we are sure that the resultant is in magnitude is 305 and in direction that means angle made by the resultant with horizontal is 31.6. But what is the distance of that particular resultant force with respect to this point, given point A? So we need to make sure that resultant is either like this to left of A or to just right of A, and we have to find this distance. Okay, perpendicular distance. So first we need to find the moment of the forces, algebraic sum of moment of all the forces about the given point of interest P, and then we can say whether the resultant is acting to just left of A or to right of A. Here we need to consider the moment concept. If the algebraic sum of the moments of all the forces is clockwise, so obviously the resultant will be something like this, which will produce the clockwise rotation. Right, and if the moment, algebraic sum of moment of all the forces about this point A, if it is anti-clockwise, the resultant will be something like this, and it will produce anti-clockwise rotation. So first we have to find the rotatory effect or effect of the forces which will produce the rotation, the rotatory effect in terms of moment. Yes. So next is position of resultant force with respect to A. So how to find? We have one theorem, Varigno's theorem. So using Varigno's theorem we can find the distance. So using Varigno's theorem, whatever the moment of the forces about point A, algebraic sum, and that should be equal to what? Moment of the resultant force about A. If you are considering the components, then we need to assume so the summation of moment of x component and y component. So first we'll find this algebraic sum of moment of all the forces about point A. Okay. So this is point A. So this force 100, this 80, this 40, and this component of 200 Newton we need to consider. And along with this, there is one couple given which is clockwise in sense. So 40 Newton meter value is given. So we need to consider all of this, right? How to calculate moment? So first we need to consider the line of action of the force. For example, the line of action of the force is an imaginary line in the direction of the force, right? So this is the perpendicular distance from A, right? So what is the moment? Moment is this 40 into this perpendicular distance, which is 200 Newton, 200 mm. So in the same way, we need to find for all the forces. So starting with the assumption, we'll make the assumption anti-clockwise positive and clockwise negative. You can assume any of the assumption. Okay, you can also assume clockwise positive, anti-clockwise negative. Both the opposite signs should be given opposite sign. So I am assuming that the anti-clockwise rotation or moment is positive. So anti-clockwise is positive and clockwise is negative. So first, starting with this 40 into 200, draw just simply line of action and consider this force vector which will produce whatever moment. So let's say this 40 Newton will produce anti-clockwise rotation about point A, right? In the same way, this 100 Newton line of action is this. It is at perpendicular distance 200 Newton, right, from A. So this force will produce clockwise moment about A, 100 into 200. So 40 into 200 anti-clockwise, 100 into 200 clockwise. Forty into 200 anti-clockwise, so positive, and 100 into 200 clockwise, therefore negative. Yes. Now this line of action of this 800 Newton force, 80 Newton force, the perpendicular distance is 300, right? And it is producing what effect? It is producing anti-clockwise rotation. So 80 into 300 anti-clockwise, and this couple is 40 Newton meter clockwise. We don't need to consider the distance, it is directly a moment, right? So 80 into 300 anti-clockwise, 40 clockwise. (40 clockwise negative and 80 into 300 anti-clockwise. And last is the component of these forces, 200 cos theta. The line of action is like this. So perpendicular distance is 200 and this 200 sin theta, which is acting at this distance, which is 300 plus 300, total distance is 600. And this is going to produce anti-clockwise rotation, and in the same way this will also produce anti-clockwise. So both are considered as positive. The 200 cos theta into perpendicular distance 200 and 200 sin theta into 600. So 200 sin theta, where theta is 36.87 into 600 and 200 cos 36.87 into 200. Okay. Yes, calculate the moment. Okay, this moment is 115960.1286. I'm going to consider here 13, and force into distance, that means unit should be Newton mm, because we have considered forces in Newton and distances in mm. So this is summation of moment of all the forces about A. Okay. So next, the sign of this is positive, right? Positive. That means this moment is anti-clockwise as per our assumption. That means the resultant will produce anti-clockwise rotation about A. So for this, your resultant should lie somewhere here, right? This is the resultant force. Okay, and I'm going to find the distance. Okay, this is, let's say, D. This is the perpendicular distance. This resultant is making an angle 31.6, right? 31.6 with horizontal, and it is in this direction because horizontal component is positive, vertical component is negative. So find the distance by using the Wagner's theorem. So R into D will be the moment about A, anti-clockwise in sense. So R into D is the moment. Now moment of resultant force about D is R into D, where R is resultant force is 305.287. Now equating these two, your 305.287 into D should be equal to what? 115960.13. So distance is equal to 115960.13 divided by 305.287, which will give 379.84. Again, this is wrong. D distance is wrong. It should be 379.84. Okay, all the remaining angle, magnitude of the resultant and direction is correct, but with respect to this point A, the answer, the distance is wrong, perpendicular distance. Okay. Start. Okay, so next third numerical solve करते हैं. In the same way, this is again general force system. find the resultant of given system and locate it from point O. This is point O to extreme left, where the C1, C2 and C3 values are given 85, 65 and 90. Okay. This is clockwise, this is anti-clockwise, again this is clockwise. So first we need to find the resultant force. Now all the forces, all the point loads vertically downward or upward, those are parallel force system along with the couples. So obviously there is no x component of the resultant, so directly we are going to consider resultant that is equal to summation of y component of the forces. So resultant of the given force system okay, and that is equal to what? Summation of forces. Forces are along y axis only, so obviously, so again 50 downward, so we are going to assume upward forces positive, downward forces negative. So 50 downward, negative 50, 40, negative 40, upward 30, upward 20 and 40 downward. So it is minus 80 and that means the resultant is downward as per our assumption. Okay, so this is correct. Now they are asking to locate the resultant force from this point O. So again we are going to consider Wagner's theorem. The moment, some algebraic sum of moment of all the forces and the couples, that should be equal to moment of the resultant force about the same point of interest O. So Wagner's theorem. Location, or you can say position, of resultant force from O. So how we can find? By using again Wagner's theorem. So using Wagner's theorem, which states that the algebraic sum of moment of all the forces about the point of interest, let's say O, that should be equal to what? Moment of resultant about O. So we will find first summation of moment of given forces about O. So first state the couples. This is clockwise, so negative. This is anti-clockwise, so positive, and clockwise negative. 85, 65 and 90 respectively. 85, 65 and 90. And 85 is clockwise, so negative. Anti-clockwise 65 positive and clockwise 90 negative from on the basis of our assumption. So minus plus minus, as we are assuming the anti-clockwise moments are positive and clockwise negative. Then due to these forces, so the perpendicular distance of this 50 Newton is 0. The line of action of the force is intersecting O, that means perpendicular distance is 0, the moment will be 0. So 50 into 0, you don't need to write. Then this force 40 into 1, it is producing what? Clockwise rotation or clockwise moment. Then 40 into 1, this 30 Newton force is at distance 2, it is producing anti-clockwise moment, so 30 into 2 positive So 40 into 1 negative, 30 into 2 positive. And again this 20 Newton force will produce anti-clockwise moment. It is at distance 3, 1 plus 1 plus 1 3, and anti-clockwise. So 20 into 3 anti-clockwise, and this 40 Newton is at 4 meter. It will produce clockwise moment. So 40 into 4, 20 into 3. Okay, so find the moment algebraic sum. Negative 190, and that simply means 190 Newton meter clockwise, right? So resultant force will produce clockwise moment about O, having magnitude 190. So either this side resultant or this side, but we are sure now, as moment of all the forces is clockwise, this will be the resultant, position of resultant. Let's say here at distance x. Okay, moment is also correct, 190. Now the distance x, okay, we are not sure that whether it will act in between these or these, so just randomly you can consider any location, let's say x. So whatever the moment of resultant about O, r into distance x, or you can also consider d. So r into d clockwise, that will produce the same moment 190. So r into d. Okay, so resultant is 80 Newton. So equate these two. So 80 into d should be equal to 190, and therefore d is equal to 190 divided by 80. .375 meter, which is again correct as per your question bank. And 2.375, so exact location, if I want to show this, 2 distance is here and 2.375 somewhere here, so your resultant will be acting something like this at distance d from O, which is equal to 2.375. So you can replace these all forces by this single force R, which is having magnitude 80 Newton, direction downward, vertical downward, and at a distance 2.375. This is meter, right? Okay. So ये हमने इसलिए by using Varinus theorem solve किया. In the same way, you can solve this numerical, which is again general force system. What they are asking: find the resultant force of the given system and locate it from with respect to point A, right? So again, this is general force system in which there are forces like 200 Newton at an angle theta 1, 50 Newton, then 320 Newton, 400 Newton, and 300 Newton, which is acting at different locations. So first we need to find the angles of inclination, and then we can resolve the forces in vertical and horizontal component. And in the same way, we'll consider the conditions to find the magnitude and the direction, as well as the location with respect to given point A, right? So let's solve this. First find the angles theta 2. So you can just say that this is angle theta 2, right? And in the same way this is angle theta 1, opposite angles here, correct? So for theta 1 consider this triangle, right? This base of the triangle is 160, height is 120 mm. So theta 1 is tan inverse of opposite side upon adjacent side. $36.87. And next, for this theta 2, consider this triangle GDE. Okay, so from here you can say theta 2 is tan inverse of DE, which is 160, and GD, which is 120. So tan inverse of opposite side 160, it should be 53.13, something like that. 53.13. राइट, तो हमने फाइंड कर लिए एंगल्स. रिजॉल्व दिस फोर्सेस. सो एंगल का एडजेसेंट कंपोनेंट रहेगा कॉस कंपोनेंट, सो 200 cos theta 1 and this is going to be 200 sin theta 1 downward, and again 50 Newton, 50 sin theta 1, 50 cos theta 1, 400 cos theta 2 and 400 sin theta 2. So इसको फाइंड करेंगे हम रिजल्टेंट को by using the same earlier same steps what we have done in previous numerical. Yes, component of x, component of resultant along x axis or x component of resultant. X axis, or you can say x direction, that is equal to algebraic sum of forces along x axis. Yes, 400 cos theta 2 minus 320 and these two forces. So 400 cos theta 2 and 320. 400 cos theta 2 towards right positive. Theta 2 is 53.13 minus 320. 50 cos theta 1 and minus 200 cos theta 1. 50 cos theta 1 towards right positive. Theta 1 is 36.87 and 200 cos theta 1 towards negative direction. Okay. So it is minus 200 Newton, right? And minus sign indicates the x component of resultant is towards left. Same way, find the component of resultant force along y-axis. Yes, Ry is equal to Fy. Yes, upward force is positive, downward negative. So 300 Newton upward, 400 sine theta 2, 300 upward, 400 sine theta 2, 53.13 upward. Yes, you don't need to consider this horizontal force. 50 sine theta 1 downward minus 200 sine theta 1 downward minus. Where theta 1 is 36.87. $470 positive. Okay, and third is magnitude of the resultant force. And given by the formula R is equal to under root of Rx square plus Ry square. Rx is 200, Ry is 470. Yes. Yes, it is correct. 510.78 Newton. Okay, and x component of the resultant is towards left, y component is upward, so your resultant will be acting something like this, having an angle, let's say alpha, with horizontal. Let's find that alpha angle. Okay, direction of the resultant force. That is given by tan inverse of Ry by Rx. Ry is 470, Rx is 200. $66.8 948, you can also write 95 for example. Yes, correct. And now the position, or you can say location of resultant. Force from A, right? This A point. Okay. So again we are going to consider the Wegener's theorem. We'll first calculate the algebraic sum of the moment about this point A, and then we'll equate it with the moment of the resultant about A. So using Wegener's theorem, moment of forces about A, that should be equal to summation of moment of resultant about A, right? So first we will calculate the summation algebraic sum of moment of all the forces about A. So just consider these forces are intersecting A. That means the perpendicular distance of the line of action of the forces is 0. That means they will not produce any moment. In the same way, this 300 Newton is again intersecting point A. That means it will not produce any moment. Now we have to consider this component of the forces P, component of 50 Newton, 320, and this 400, and again there is couple 4800 clockwise. So first couple 4800. So clockwise I am going to assume it as negative. Then this 50 sine theta, it is at distance 160, it is producing clockwise moment, and this 50 cos theta is again line of action is intersecting point A. That means it will not produce any kind of moment. So 50 sine theta into 160, theta 1 actually, and clockwise minus theta 1 is 36.87. The next is 320. The line of action is like this. It is at perpendicular distance 120 Newton. It tends to produce anti-clockwise rotation. So 320 into 120, anti-clockwise positive. Then these two forces. So the line of action of these 400 sine theta is like this. It is at perpendicular distance 120. It tends to produce anti-clockwise rotation. So 400 sine theta 2 into 120. 400 sine theta. Theta 2 is 53.13. Perpendicular distance is 120. And then this force tends to produce clockwise moment, right? Total perpendicular distance is 280. So clockwise therefore minus 400 cos 53.13 into 280. The answer is 0.2229. So it is approximately 0 as we have considered these angles 36.87 and 53.13. If you consider the exact angles, you will get this moment as 0. And that simply means the moment of the resultant is also 0. So the moment of resultant about A, which is R into D, so we can equate this with 0. That means D is 0. So that simply means the resultant will exactly act at this point A. The line of action of the resultant will intersect point A. The direction of the resultant is 66.95. Let me show 66.95. Something like this. This is the line of action of the resultant at angle alpha and through point A. Okay, तो हमने सॉल्व किया जनरल फोर्स सिस्टम न्यूमेरिकल, इसमें हमने फाइंड किया है रिजल्टेंट, द पोजीशन ऑफ द रिजल्टेंट, डायरेक्शन ऑफ द रिजल्टेंट. दिस इज आल्सो करेक्ट. सो आइए सॉल्व करते हैं अभी नेक्स्ट न्यूमेरिकल. जो सेंट्रॉइड टॉपिक से आया, राइट. सो सेंट्रॉइड टॉपिक के न्यूमेरिकल के लिए आपको क्या चाहिए? स्टैंडर्ड जो प्रिमिटिव फिगर्स है उसके फॉर्मूलास पता होना चाहिए एरिया एंड सेंट्रॉइड के. सो दिस इज गिवन, लोकेट द सेंट्रॉइड फॉर द गिवन शेप. दिस इज द शेप. So first we need to identify the primitive figures, the combination of the primitive figures from this given composite section. So for this diagram what we can do is we need to find the minimum number of primitive figures or standard figures from this. So we can just add these two shapes, right? So this one is semicircle, which is standard, but this is not standard case. So what we can do is we can consider this rectangle and we can subtract this shape, which is quarter circle. So the given figure is the combination of this rectangle. Then you can subtract this quarter circle in order to get this shape, and you can just add semicircle, right? So this is the combination of rectangle minus this quarter circle plus this semicircle. Okay. So using moment of area concept, we have derived the formula that the x coordinate of the resultant is equal to what? Summation of ax upon summation of a, right? And in the same way y coordinate of the y coordinate of the centroid is summation of a y upon summation of a. So a given figure is a combination of three standard figure. So what we can write is x bar is a1 x1 minus y minus, because second figure we are taking, this is first, second and third figure. So we are subtracting the second figure, that means a2 x2 plus a3 x3 whole divided by a1 minus a2 plus a3, and similarly y bar is a1 y1 minus a2 y2 plus a3 y3 whole divided by a1 minus a2 plus a3. So we are going to find first the area and centroidal distance. Where is the origin given? Here, right? Yes, first rectangle, okay, and this is the xy axis. This is origin. The centroid is here, right? This is going to be y1 and x1. क्या रहेगा ये value? So first, here radius 20, right? This means this is also 20. This is also 20. So it is square actually of size 20, and unit is centimeter. Okay. So area for this diagram क्या रहेगा area 20 into 20 400 centimeter square. Then x1, this distance center right, that means half of 20, 10 centimeter, and y1 similar way, half of height 20, that means half of 20 is 10 centimeter. Yes. Second figure. Yes. X and Y, and right, this is your quarter circle, and the centroid is somewhere here. ओके, ये डिस्टेंस क्या होगा y2, जिसको हमने सेकेंड नाम दिया, राइट? दिस इज g2 सेंट्रॉइड, g2 g1 एंड ये डिस्टेंस होगा x2, राइट? द रेडियस इज 20 for this quarter circle. Yes. So first find area for the second diagram. This is quarter circle, that means area of circle divided by 4. So pi r square by 4, where radius is 20. Hundred into pi also you can write, or 314.159 or 16 centimeter square. Then both x2 is standard formula 4r by 3 pi. So 4r 20 divided by 3 pi. 8.488 centimeter. And y2, this distance is 4r by 3 pi. So we need this distance. Total is r. So this is going to be y is r minus 4r by 3 pi. Eleven point 11.512. And for third diagram, third is semicircle. This one, right? Having radius 10. But it is at 20 centimeter from origin. Centroid is here somewhere, G3. This is Y3 and this distance is X3. Yes, first find area. Area of semicircle, pi r square by 2, radius is 10. One 57.079 or 08 centimeter square. Then x3, this is 20 plus this distance is 4r by 3 pi. So 20 plus 4r by 3 pi, where radius for this is different, 10. Yes. .244 centimeter, and y3 is simply a radius, right? So it is 10 centimeter. Now substitute all the values in formula. Start. Let's find x coordinate of the centroid, and that is equal to a1 x1 minus a2 x2 plus a3 x3 A1 minus A2 plus A3. So A1 is 400, X1 is 10, right? A2 is 314.16 and X2 is 8.488 and A3 is 157.08 and X3 is 24.244. So it is 314.16 into 8.488 and plus 157.08 into 24.244. It is 21.166 centimeter. And then y coordinate of centroid, y bar A1 y1 minus A2 y2 plus A3 y3. Okay. Yes. Y2 is 11.512. Y3 is 10. Now solve for y bar. So it is 8.0445 centimeter. Okay, so we can just locate somewhere x bar is 21.166 and y bar is 8.0445. So 21 point something. Here you can locate the G, where this distance is x bar 21.166 and y bar is 8.044 सेंटीमीटर. ओके, तो हमने सॉल्व किया सेंट्रॉइड का न्यूमेरिकल. So hello students, we have a regular batch going on in Ganesh Academy, as well as we are going to start a new batch after your unit test. So please join, and together we can grow, we can solve this engineering mechanics end semester exam very easily. It's quite intriguing subject for the first year students. So I'll be here to help you with this engineering mechanics subject. Thank you.